Hey everyone, welcome back to the channel. If you're preparing for the AI-901 Microsoft Azure AI Fundamentals exam, you're in exactly the right place. In this video, we're diving into a complete crash course that covers all the key concepts you need to pass the exam fast and efficiently. We'll break down topics like artificial intelligence concepts, generative AI and agents, computer vision, NLP, and AI speech concepts, all explained in a simple, easy-to-understand way. And that's not all. You'll also get realistic practice questions to test your knowledge and boost your confidence before exam day. Whether you're a beginner or doing last-minute revision, this video will help you get exam ready. So make sure to hit that like button, subscribe for more certification content, and let's get started.
AI concepts for developers and technology professionals. Introduction to AI concepts.
Welcome! If you are here, you are probably curious about artificial intelligence, or AI. Maybe you have seen AI in the news, or you are preparing to use it at work or school. This training module offers a high-level overview of the core capabilities of artificial intelligence. You will gain an intuition for how AI works without diving into technical details or writing code. We will not cover the mathematics behind machine learning models, but instead focus on what AI can do and the basic principles that guide it. Whether you are a beginner or just looking to understand AI better, this module is designed for you. Next steps. Let us begin our journey into artificial intelligence, move on to the next unit, and start exploring the fascinating world of AI. What is generative AI? Generative artificial intelligence, or generative AI, is a branch of artificial intelligence that enables software to create new content. This content can include natural language conversations, images, videos, computer code, and more, making generative AI a versatile and powerful technology. How does generative AI work? Generative AI relies on language models that have been trained using massive amounts of data, often sourced from the internet or other public information. Users interact with these models by providing prompts, which are natural language questions or statements. The model then generates a meaningful response by understanding the relationships between words and concepts, allowing it to produce coherent and relevant content. Types of language models. There are large language models, or LLMs, and small language models, or SLMs. LLMs are trained on vast data sets and can handle a wide range of topics, but they require significant resources. SLMs are more focused, making them ideal for specific tasks or for use on local devices. Common uses of generative AI. Generative AI is used to create AI agents that assist users, generate new documents, automate translation between languages, and summarize or explain complex information. These applications help streamline tasks and enhance productivity across many industries. Natural language processing, or NLP, is a field of artificial intelligence focused on helping computers understand and interpret human language. It is the foundation for generative AI large language models, often called LLMs, and powers many modern text analysis solutions. Core text analysis techniques. NLP uses a range of techniques to analyze and summarize natural language text. Language detection identifies which language a document is written in, often as the first step in processing. Text classification assigns documents to categories, including sentiment analysis, to determine if the tone is positive, negative, or neutral. Key term extraction and entity detection find important words, phrases, or mentions of people, places, and organizations. A specialized form of entity detection is redacting personally identifiable information, such as names or addresses, to protect privacy. Summarization condenses large volumes of text while preserving the main ideas. Real-world applications. NLP technologies are used to analyze documents, meeting transcripts, and social media posts to identify key topics and sentiment. They also power chatbots that answer common questions and help redact sensitive information to comply with privacy laws. From analyzing opinions to protecting privacy, NLP is essential for making sense of language in today's digital world. Speech capabilities in artificial intelligence applications and agents are transforming how people interact with technology. By enabling communication through spoken language, these systems make digital experiences more natural and accessible for everyone. Core speech technologies. At the heart of these capabilities are two key technologies. First, speech recognition allows artificial intelligence to hear and interpret speech, typically by converting spoken words into written text through speech-to-text systems. Second, speech synthesis gives artificial intelligence the power to vocalize words as spoken language, using text-to-speech technology to turn written information into audible speech. Advancements in AI speech. Artificial intelligence speech technology is advancing rapidly. Modern systems are learning to ignore background noise, detect interruptions, and generate voices that sound increasingly expressive and human-like. These improvements are making interactions with artificial intelligences smoother and more engaging. Real-world applications. Common uses of artificial intelligence speech technologies include agents that understand spoken commands, automated transcription of calls or meetings, audio descriptions for videos or text, and automated speech translation between languages.
Computer vision is a branch of artificial intelligence focused on analyzing visual input, such as photographs, videos, and live camera feeds. By teaching computers to interpret images, computer vision enables machines to understand and interact with the visual world. How computer vision works. Computer vision relies on training models with vast numbers of images. These models learn to recognize patterns, objects, and features by analyzing labeled examples. Once trained, they can interpret new, unlabeled images and make predictions about what they see. Types of computer vision models. There are several types of computer vision models. Image classification models identify the main subject in an image. Object detection models go further, pinpointing the location of specific objects. Semantic segmentation is even more advanced, identifying the exact pixels that belong to each object. Multimodal models combine visual features with text descriptions, allowing them to generate detailed descriptions of images. Real-world applications. Computer vision powers many everyday technologies. It enables artificial intelligence agents to interpret visual input, generates captions or tags for photos, and supports visual search. In retail, it helps monitor stock levels and identify items at checkout. Computer vision is also used in security video monitoring, facial recognition for authentication, robotics, and self-driving vehicles. Artificial intelligence is transforming the way we handle information by automating information extraction from unstructured data sources. Whether it is scanned documents, forms, images, or even audio and video recordings, AI can find valuable information and unlock insights that were previously hidden. How information extraction works. At the core of most document analysis solutions is a computer vision technology called optical character recognition, or OCR. OCR identifies the location of text within an image, making it possible to digitize printed or handwritten content. But OCR is just the beginning. It is often paired with analytical models that interpret individual values, allowing the extraction of specific fields. For example, matching text from a receipt to fields in an expense claim submission. Expanding beyond text. While traditional data extraction models focused on text-based forms, advancements in AI now enable extraction from audio recordings, images, and videos. These more sophisticated models are becoming increasingly accessible, broadening the scope of what can be analyzed and understood. Common use cases. AI-powered information extraction is used for automated processing of business documents, large-scale digitization of paper forms like census records, indexing documents for search, and identifying key points or follow-up actions from meeting transcripts or recordings. Responsible AI means building artificial intelligence systems with safeguards to prevent harmful, illegal, or offensive outcomes. It is about ensuring that AI technologies are developed and used in ways that are ethical, safe, and beneficial for everyone. Principles of responsible AI. There are several key principles behind responsible AI. Fairness is crucial, as AI models can inherit biases from the data they are trained on. Developers must minimize these biases to avoid discrimination. Reliability and safety are also essential, since AI is not perfect and can make mistakes. Privacy and security matter too, because personal data must be protected throughout the AI lifecycle. Inclusiveness ensures that AI solutions are accessible to all users, not just a select few. Transparency helps users understand how AI works and its limitations. Finally, accountability means organizations must take responsibility for their AI systems and apply strong governance frameworks. Real-world examples. For example, a college admissions AI should be tested for fairness to avoid bias. A robotic system should only act when it is confident in its object detection. Facial recognition at airports must delete images after use. AI agents should provide captions for accessibility, and banks must disclose how AI is used in loan decisions. Responsible AI is about building trust, protecting people, and ensuring technology works for everyone.
Question 1. Which is the most accurate description of generative AI? A. Generative AI uses a language model to create original content in response to a prompt. B. Generative AI is an older form of AI that's superseded by machine learning. C. Generative AI is a complex form of AI that can only be used by specialists such as data scientists. The correct answer is option A. Question 2. What is an AI agent? A. A technology professional who builds AI applications. B. Anyone who uses AI applications. C. An AI application that can perform tasks on behalf of a user. The correct answer is option C. Question 3. An AI application reads email aloud to a user. Which AI speech capability is being used? A. Speech recognition. B. Speech synthesis. C. Sentiment analysis. The correct answer is option B. Introduction to Generative AI and Agents. Generative artificial intelligence, or generative AI, is quickly becoming a familiar term, even for those outside the world of technology. Its ability to create original content that feels remarkably human has captured the imagination of people everywhere. The magic of generative AI. Futurist and novelist Arthur C. Clarke once said, "Any sufficiently advanced technology is indistinguishable from magic," said Arthur C. Clarke. Generative AI certainly fits this description, producing poetry, stories, and even computer code that can seem almost miraculous. But behind the scenes, there is no actual wizardry at work. Instead, generative AI relies on years of research in statistics, data science, and machine learning to achieve these impressive results. How generative AI works. At its core, generative AI uses mathematical techniques to analyze vast amounts of data, learning patterns and structures that allow it to generate new, original content. These methods have been incrementally discovered and refined over time, making today's AI agents more capable than ever before. By understanding these core concepts, anyone can begin to see how the magic trick is performed. Looking to the future. As generative AI continues to evolve, learning about its principles empowers us to imagine new possibilities for tomorrow's technology. Large language models, or LLMs, are at the heart of generative artificial intelligence. These models, along with their smaller counterparts called small language models, capture the complex relationships between words and phrases, allowing them to understand and generate meaningful language. How large language models predict language. LLMs are trained to generate completions based on prompts, much like an advanced version of predictive text on your cell phone. When given a prompt, the model predicts the most likely next word by analyzing which words in the sequence are most influential, ensuring the response is both relevant and coherent. The role of tokens. Instead of thinking in terms of whole words, LLMs use tokens. Tokens can be entire words, subwords like in unbelievable, punctuation, or other common character sequences. This approach allows the model to handle a vast vocabulary, often consisting of hundreds of thousands of tokens. Training with tokens. Training begins by breaking down massive amounts of text into these tokens, each assigned a unique identifier. As more data is added, the vocabulary grows, enabling the model to recognize and generate a wide range of language, from simple words to complex phrases. Transformers are powerful models that help computers understand language by relating words or tokens to each other. But how does this actually work? Let's break it down. Token embeddings and attention. First, each token is assigned a unique vector, which is just a list of numbers. These vectors start out random, but they're transformed into embeddings that capture the meaning and context of each token. To do this, transformers use a technique called attention. Attention looks at each token and weighs how much nearby tokens influence its meaning. For example, in the phrase, "I heard a dog bark," the words dog and heard are more important for understanding bark than I or a. Encoder and decoder blocks. A transformer has two main parts, the encoder and the decoder. The encoder uses attention to create embeddings, while the decoder uses those embeddings to predict what comes next in a sequence. Multi-head attention lets the model consider different aspects of meaning at once, making the process efficient. Predicting the next token. When given a prompt, the decoder predicts the next most likely token, one at a time, using attention and a neural network. This process repeats until the sequence is complete. A prompt is simply the input you give to a large language model, or LLM, to get a response. It could be a question, a command, or even a casual comment to start a conversation. The model replies with what's called a completion. Types of prompts. There are two main types of prompts. System prompts set the behavior, tone, and constraints for the model. For example, you might tell the model to act as a helpful assistant with a friendly manner. User prompts, on the other hand, are specific questions or instructions from the user, like asking for a summary or a list. Conversation history. Generative AI applications often keep track of conversation history. By including previous prompts and responses, the model maintains context, making its answers more relevant and consistent as the conversation continues. Retrieval augmented generation. Retrieval augmented generation, or RAG, adds even more context. The application retrieves relevant documents or data, then includes that information in the prompt. This helps the model give answers grounded in real, specific information. Tips for better prompts. To get the best results, be clear and specific, add context, provide examples, and ask for structured responses. Well-designed prompts make a huge difference in the quality of generative AI outputs. Imagine a digital assistant that does more than just answer your questions. Welcome to the world of AI agents. These are software applications powered by generative artificial intelligence designed to reason, generate natural language, and automate tasks in real time. Components of an AI agent. Every AI agent is built from three essential elements. First, there is a large language model, which acts as the agent's brain, enabling it to understand and reason with language. Second, instructions, known as system prompts, define the agent's role and behavior, much like a job description. Third, tools allow the agent to interact with the world, making it capable of more than just conversation. Tools and capabilities. AI agents use knowledge tools, such as search engines or databases, to access information. They also have action tools that let them perform tasks like sending emails, updating calendars, or even controlling devices. With these abilities, AI agents can automate tasks and collaborate with you to boost efficiency. Multi-agent systems. AI agents can also work together in multi-agent systems. Each agent specializes in a task, collaborating through prompts to complete complex workflows, much like a human team. The future of agentic AI. Agentic AI is poised to transform how we find information and get work done, making technology smarter and more collaborative than ever. Question 1. What is a large language model, LLM? A type of AI model designed to generate human-like text. B. A model that only processes images, not text. C. A small, efficient model for mobile devices. The correct answer is option A.
Question 2. What is the purpose of tokenization? A. To sort the words in a sentence alphabetically. B. To break down text into smaller units. C. To convert text into binary code for processing by computers.
The correct answer is option B. Question 3. What are embeddings?
A. Extra words added by a transformer model to enhance text generation. B. Small language models used for specific tasks. C. Vector-based representations of tokens that capture their semantic meaning. The correct answer is option C.
Question 4. What does an attention layer do in a transformer model? A. Removes irrelevant words from the input text. B. Examines the relationships between each token and the tokens around it. C. Flags inappropriate content in the generated text.
The correct answer is option B.
Question 5. What is the purpose of a system prompt? A. To provide context and instructions to the AI model. B. To configure a generative AI model to run on a particular operating system. C. To store user preferences for future interactions.
The correct answer is option A.
Question 6. What is an agent in the context of AI? A. An AI system that can perform tasks on behalf of a user. B. A generative AI model that operates in secret. A human operator to whom generative AI models escalate requests they can't handle.
The correct answer is option A.
Introduction to Natural Language Processing Concepts.
Text analysis is a crucial part of artificial intelligence, specifically within natural language processing, or NLP. It allows machines to extract meaning, structure, and insights from unstructured text. Organizations rely on text analysis to turn sources like customer feedback, support tickets, contracts, and social media posts into actionable intelligence. Key techniques and use cases. Over the years, text analysis techniques have evolved from simple term frequency calculations to advanced vector-based language models that capture semantic meaning. Common use cases include language detection, which identifies the language of a text, and key term extraction, which highlights important words and phrases. Entity recognition finds names of people, places, dates, and organizations. Identifying and redacting personally identifiable information, or PII, helps protect sensitive data. Text classification sorts documents by content, such as filtering emails as spam or not spam. Sentiment analysis predicts whether text expresses positive, neutral, or negative feelings. Text summarization condenses lengthy documents into concise summaries, making information easier to digest. Challenges and the importance of meaning. Despite these advances, text analysis remains challenging because language is inherently complex and nuanced. All techniques ultimately aim to extract meaning from natural language, helping computers better understand and process human communication.
Text tokenization is the process of breaking down a body of text, or corpus, into smaller pieces called tokens. Typically, each distinct word becomes a token, but tokens can also include partial words or combinations with punctuation. Tokenization example. Take the phrase, "We choose to go to the moon." Each word is a token. We choose to go to the moon. Notice "to" appears twice, showing how tokens can repeat. Why tokenization matters. Assigning discrete values to tokens allows us to count their frequency. This helps identify the most commonly used terms and can reveal the main subject of the text. Pre-processing techniques overview.
Before tokenization, several pre-processing techniques can be applied to improve analysis, depending on your goals. These include text normalization, stop word removal, n-gram extraction, stumming, and lemmatization. Text normalization. Text normalization involves removing punctuation and converting words to lowercase. While this improves performance, it may lose some semantic meaning. Stop word removal. Stop words like the or it are excluded to focus on more meaningful words, making analysis more effective. N-gram extraction. N-gram extraction identifies multi-word phrases, such as artificial intelligence, to better capture important concepts. Stemming and lemmatization. Stemming strips word endings, while lemmatization reduces words to their dictionary form, ensuring accurate analysis. When analyzing large collections of text, or corpora, statistical techniques help uncover meaning and structure. Let's explore 4 essential methods: frequency analysis, term frequency inverse document frequency, bag of words for machine learning, and text rank summarization. Frequency analysis. Frequency analysis is the simplest approach. By counting how often each word appears, you can quickly identify the main topics. For example, if AI and business are the most frequent terms, the document likely discusses artificial intelligence in business contexts. TF-IDF. Term frequency inverse document frequency, or TF-IDF, refines this by highlighting words that are common in one document but rare across the entire corpus. This helps distinguish what makes each document unique. For instance, Copilot might stand out in one document, while Foundry is unique to another. Bag of words and machine learning. The bag of words technique represents text as word frequency vectors, ignoring grammar and order. This is the foundation for machine learning models like naive Bayes, which can classify emails as spam or not, or perform sentiment analysis. Text rank summarization. Text rank is a graph-based algorithm that summarizes text by ranking sentences based on their similarity. The highest ranked sentences form a concise summary, capturing the document's key points efficiently. Modern language models use vectors, or multidimensional arrays of numbers, to represent words and their meanings. This approach, known as embeddings, allows models to capture the semantic relationships between words, making text analysis more powerful and efficient. How vectors represent meaning. Each word is mapped to a point in multidimensional space. Words with similar meanings, like dog and cat, have vectors that point in similar directions. For example, dog might be represented as 0.8, 0.6, 0.1, while cat is 0.7, 0.5, 0.2. Their closeness reflects their semantic similarity. Comparing words with cosine similarity. To measure how similar two words are, models use cosine similarity. For instance, dog and cat have a high similarity score of 0.992, while dog and tree score much lower at 0.333. This helps identify which words are most alike or the odd one out. Vector arithmetic and analyses. Vector arithmetic lets us perform operations like dog plus young equals puppy. Similarly, kitten minus puppy plus dog results in cat. These calculations reveal deep linguistic relationships and analogies. Applications in text analysis. Vector-based models power tasks like summarization, keyword extraction, named entity recognition, and text classification. By leveraging semantic similarities, these models efficiently analyze and organize language, forming the backbone of modern natural language processing. Question 1. What is the purpose of tokenization? A. To translate text into another language. B. To summarize large documents. C. To break down text into smaller units for analysis.
The correct answer is option C.
Question 2. Which of the following techniques is used to determine the importance of words in a specific document within the context of a larger collection of documents? A. Naive Bayes. B. TF-IDF, term frequency inverse document frequency. C. Word-to-vec.
The correct answer is option B.
Question 3. Which of the following best describes the role of embedding vectors in natural language processing, or NLP? A. They duplicate tokens in multiple languages. B. They define stop words that should be ignored. C. They capture semantic token relationships in multiple dimensions.
The correct answer is option C.
Introduction to AI speech concepts. Speech is one of the most natural ways humans communicate, making it a powerful tool for artificial intelligence applications. Integrating speech capabilities into AI creates more intuitive, accessible, and engaging experiences for users, whether in daily tasks or specialized applications. Core capabilities: recognition and synthesis. There are two fundamental speech technologies at the heart of voice-enabled applications. Speech recognition converts spoken words into text, allowing AI to understand and process what users say. Speech synthesis, on the other hand, transforms written text into natural-sounding speech, enabling AI to respond in a human-like voice. Together, these technologies enable seamless conversational interactions between people and machines. Real-world impact. From voice assistants to accessible applications and conversational AI agents, speech technologies are essential for modern AI solutions. Understanding how these capabilities work can help developers create transformative user experiences across a wide range of real-world scenarios. Speech recognition is transforming how we interact with artificial intelligence applications. By combining speech recognition, which converts spoken words into text, and speech synthesis, which generates natural-sounding audio from text, these technologies enable hands-free operation, improve accessibility, and create more natural conversations. Speech recognition in action. Speech recognition, also known as speech-to-text, powers a wide range of applications. In customer service, it transcribes calls in real time, routes callers, and analyzes sentiment. Virtual assistants accept voice commands, answer questions, and control smart devices. In healthcare, clinicians dictate patient notes directly into electronic health records, reducing administrative burden and improving documentation accuracy. Speech synthesis in action. Speech synthesis, or text-to-speech, brings written content to life. AI agents respond with natural voices, making interactions more engaging. Applications read web content aloud for users with visual impairments or reading disabilities. Educational platforms create narrated lessons, while entertainment creators generate character voices and voiceovers for games and videos. Combining speech capabilities. The most powerful experiences combine both technologies. Voice-driven customer service agents listen and respond conversationally. Interactive voice response systems guide callers naturally. Language learning apps provide spoken feedback, and voice-controlled vehicles enable hands-free operation and updates. Key considerations. Before implementing speech, consider audio quality, language support, privacy, latency, and accessibility standards to ensure an inclusive and effective user experience. Speech recognition starts with a microphone, turning sound waves into digital signals. These signals are sampled thousands of times per second, often at 16,000 samples per second, to capture every detail of your voice. Feature extraction. Next, the system cleans up the audio, removing background noise. It then transforms the raw sound into a compact form using mel-frequency cepstral coefficients, or MFCCs. This process highlights the most important speech features, making it easier for the system to understand. Acoustic modeling. Now, deep learning models called transformers analyze these features. They predict phonemes, which are the smallest units of sound in language. For example, the word cat is made up of 3 phonemes, k, a, and t. But recognizing sounds is not enough. Language models step in, using grammar and vocabulary knowledge to predict which words make sense together. This helps the system choose between words like there and there. Decoding. Decoding algorithms then search through possible word combinations, balancing what was heard with what makes sense to select the most accurate transcription. Post-processing. Finally, post-processing polishes the text, adding punctuation, capitalization, and formatting numbers, ensuring the output is clear and readable. That is how speech becomes text. Speech synthesis, also known as text-to-speech, or TTS, transforms written words into lifelike spoken audio. You hear it when your phone reads notifications, navigation apps announce directions, or accessibility tools narrate text aloud. Text normalization. The first step is text normalization. This stage prepares raw text for speech by expanding abbreviations, numbers, and symbols into their spoken forms. For example, Dr. Smith ordered 3 items for $25.50 on 12/15/2023 becomes Dr. Smith ordered 3 items for $25.50 on December 15th, 2023. This ensures the system produces natural, understandable speech. Linguistic analysis and G2P. Next, linguistic analysis breaks the normalized text into phonemes, the smallest units of sound. Grapheme to phoneme, or G2P, conversion maps letters to sounds, handling tricky English spellings like though, through, and cough. Neural networks help manage unknown words and context, ensuring accurate pronunciation.
Prosody gives speech its rhythm, stress, and intonation. Transformer neural networks predict how to say each word, adjusting pitch, duration, and emphasis. This makes speech sound expressive, not robotic, and helps listeners understand meaning and emotion. Waveform generation. Finally, neural vocoders like WaveNet generate the audio waveform, turning phonemes and prosody into clear, natural-sounding speech. The result is high-quality audio produced in real time. That is how speech synthesis brings text to life, one word at a time.
Question 1. What activity happens during the pre-processing stage of speech recognition? The audio is converted to .wmv format. Background noise is added to the audio signal. Feature vectors are extracted from the audio waveform for modeling.
The correct answer is option C.
Question 2. What are phonemes? Artifacts that are removed from the signal as part of the cleanup process. The smallest unit of sound in speech. AI models that generate audio.
The correct answer is option B.
Question 3. Why is it important to generate prosody in speech synthesis? Prosody maximizes the volume of the audio output. Prosody translates the speech to the language of the listener. Prosody ensures natural pronunciation and speech cadence.
The correct answer is option C.
Introduction to computer vision concepts. Computer vision is a fundamental area of artificial intelligence, or AI, focused on enabling machines to process and understand visual information. Unlike humans, computers do not have biological eyes, but they can analyze images from cameras, photographs, or videos. Real-world applications. Think about an autonomous vehicle navigating city streets. It must detect traffic signals, recognize pedestrians, and respond to obstacles. Or consider a store using smart checkouts, where cameras identify the products in a customer's basket. Even a doorbell camera that detects people at your front door relies on computer vision. These examples show how computer vision powers everyday technology, making our lives safer and more convenient. How computer vision works. The key to computer vision is processing images in a way that emulates human visual perception. By analyzing visual data, AI applications can interpret and respond to their environment, whether it is a live camera feed or a digital photograph. In this module, we will explore the essential building blocks behind modern computer vision solutions. Computer vision is a branch of artificial intelligence that enables computers to process and understand visual information from images, videos, or live camera feeds.
Over the years, computer vision techniques have evolved, allowing machines to interpret the world visually, much like humans do. Key techniques: image classification and object detection. One foundational technique is image classification. Here, a model is trained with thousands of labeled images to predict what's in a new image. For example, in a grocery store, a smart checkout system could identify apples, oranges, or bananas placed on a scale, charging customers automatically. For more complex scenarios, object detection is used. This method scans an image for multiple items, identifying each object and its location using rectangular bounding boxes. Advanced methods: semantic segmentation and contextual analysis. Semantic segmentation takes things further by classifying every pixel in an image, offering a highly detailed understanding of object locations. The latest multimodal models go beyond objects, analyzing relationships between items and the text that describes them, enabling computers to generate descriptions or suggest relevant tags. Real-world example and impact. Imagine a system recognizing not just an apple, but also a person eating it. Computer vision is transforming industries, making everyday tasks smarter and more efficient.
To a computer, an image is just an array of numbers. Each number represents a pixel, with values ranging from 0 for black to 255 for white. For example, a 7x7 grid of numbers forms a simple grayscale image. Color images and channels. Most digital images are not just grayscale. They use 3 layers, called channels, to represent red, green, and blue colors. This is known as the RGB model. By combining different values in each channel, computers can display millions of colors. What are filters? Filters are a powerful tool in image processing. A filter uses a small array of numbers, called a kernel, to modify pixel values and create visual effects. For example, a 3x3 kernel can highlight edges or blur an image. How filtering works. The filter kernel is moved across the image, multiplying its values with the underlying pixels and summing the results. This process is called convolution. Sometimes the resulting values are outside the normal range, so they are adjusted to fit between 0 and 255. Effects of filters. Different filters can sharpen, blur, or even invert colors in an image. The Laplace filter, for example, highlights the edges of objects, making shapes stand out more clearly. Filters are essential for many image editing and computer vision tasks.
Convolutional neural networks, or CNNs, are a powerful deep learning architecture used in computer vision. Unlike traditional image filters that simply apply effects, CNNs are designed to extract meaningful features from images to help machines understand what they see. How CNNs process images. CNNs use layers of filters, also called kernels, to scan images and generate numeric feature maps. These feature maps highlight important visual patterns, like edges or textures. As images pass through multiple filter layers, the network captures increasingly complex features. The resulting feature maps are then flattened into a single array of numbers, which represent the essential characteristics of the image. Training a CNN. During training, CNNs start with randomly assigned filter weights. Images with known labels, such as apples, bananas, or oranges, are fed into the network. The model predicts a label, and its output is compared to the actual label. The difference, called loss, is used to adjust the filter and network weights. This process repeats over many epochs, gradually improving accuracy. Using the trained model. Once trained, the CNN uses its learned weights to predict labels for new, unlabeled images. This enables the model to classify images based on the features it has learned to recognize.
Convolutional neural networks, or CNNs, have long been the backbone of computer vision. They excel at tasks like image classification and object detection by extracting features from images and identifying regions of interest, driving many advances in visual AI. Transformers in NLP. In natural language processing, or NLP, a different architecture called the transformer has revolutionized language models. Transformers process vast amounts of text, encoding words or phrases as vectors using a technique called attention. This creates embeddings that capture the context and relationships between words. Vision transformers. Inspired by their success in language, researchers developed vision transformers, or VITs, for image data. Instead of words, VITs break images into patches, generating vectors based on visual features like color, shape, and texture. Attention mechanisms then map contextual relationships between these patches. Multimodal models. When images are paired with text, both language and vision transformers can be combined into multimodal models. Using cross-modal attention, these models create unified representations, linking visual features with language and enabling complex image descriptions, even for images never seen before. Summary. CNNs, transformers, and multimodal models each play a unique role in AI, advancing our ability to understand images, language, and their connections, powering everything from object detection to sophisticated image captioning.
Artificial intelligence can now create images and videos from simple text prompts thanks to advanced multimodal model architectures. These models understand both language and visuals, allowing them to generate detailed pictures or even moving scenes based on a written description. How diffusion models work. Most modern image generation models use a process called diffusion. Here's how it works. The model starts with a random set of pixel values, essentially visual noise. Using the text prompt, such as a dog carrying a stick in its mouth, the model identifies visual features that match the description. Through multiple iterations, the model gradually removes noise and adds structure, refining the image step by step. After each round, it checks how closely the image matches the prompt, repeating this process until the final, detailed image is produced. From images to video, adding motion and logic. Some models extend this approach to video generation. They use the same diffusion technique, but add extra layers of complexity. The model considers how objects behave in the real world, like making sure a dog's feet stay on the ground, and ensures the video unfolds in a logical sequence. AI image and video generation is transforming creativity, using language and visual understanding to bring ideas to life, one prompt at a time.
Question 1. Computer vision is based on the manipulation and analysis of what kinds of values in an image? Timestamps and photograph metadata? Pixels? Image file names? The correct answer is option B. Question 2. What is the primary role of filters in a convolutional neural network CNN used for image classification? To apply visual effects to enhance image appearance? To extract numeric features from images for use in a neural network? To compress image size for faster processing? The correct answer is option B. Question 3. Which description best matches a vision transformer, VIT?
A tool that applies filters to images, changing their visual appearance. An AI agent that converts a large language model to a vision model. A model that uses attention to process image patches and create contextual embeddings.
The correct answer is option C. Six, Introduction to AI-powered information extraction concepts.
Introduction to AI information extraction solutions are transforming how we handle unstructured data. These tools can pull structured data fields from documents, images, videos, and even audio recordings, making sense of information that was once difficult to access. Real-world scenarios. From simple apps that read contact details off a business card photo to advanced systems that automate entire business workflows, AI information extraction is everywhere. It powers solutions that analyze financial documents, process legal contracts, and even interpret healthcare records, streamlining operations across industries.
Financial and legal document processing. In finance, AI can process invoices by extracting vendor names, addresses, invoice numbers, payment terms, and line items like product descriptions and totals. For legal and compliance documents, AI identifies contracting parties, effective dates, payment schedules, and regulatory reporting fields. This automation reduces manual effort and increases accuracy. Healthcare and logistics applications. In healthcare, AI retrieves patient demographics, diagnoses, and billing codes from medical records. In logistics, it extracts shipment tracking numbers, sender and recipient details, and customs documentation from shipping papers and purchase orders, ensuring smooth supply chain operations.
The impact of AI extraction? By automating information extraction, organizations can boost efficiency, reduce errors, and unlock valuable insights from their data.
Information extraction is a powerful workload that brings together multiple artificial intelligence techniques to pull structured data from unstructured content, such as digital documents. This process is essential for organizations looking to automate and streamline data handling. How information extraction works. A comprehensive information extraction solution typically starts with computer vision to detect text in image-based data. Optical character recognition, or OCR, is then used to extract that text. Next, machine learning or generative artificial intelligence semantically maps the extracted text to specific data fields, making the information usable. Real-world example. For instance, an AI-powered expense claim processing system can automatically extract key fields from scanned receipts. Details like vendor name, date, subtotal, tax, and total claim are identified and mapped, enabling faster and more accurate claims processing.
Key considerations for implementation. When planning an information extraction solution, consider the characteristics of your documents. Standardized forms may suit template-based approaches, while varied layouts might require machine learning. High-volume processing benefits from automation, but critical applications may need human-in-the-loop validation for accuracy. Technical infrastructure and security. Finally, ensure your technical infrastructure supports the workload. Prioritize security and privacy for sensitive data, assess processing power needs, and consider scalability and integration requirements for seamless deployment.
Optical character recognition, or OCR, is a technology that transforms images containing text like scanned documents, photos, or screenshots into editable and searchable digital text. Instead of manually typing out information, OCR automates the process. The OCR pipeline overview. The OCR process follows a structured pipeline with 5 main stages: image acquisition, pre-processing, text region detection, character recognition, and output generation. Each stage plays a crucial role in accurately converting visual text into usable data. Key stages explained. First, an image is captured, whether from a scanner, camera, or PDF. Next, pre-processing enhances the image by reducing noise, adjusting contrast, correcting skew, and optimizing resolution. Then, the system detects text regions, distinguishing between text, images, and layout elements. Character recognition follows, where advanced algorithms and neural networks identify individual letters and words, even correcting errors using language models. Finally, the recognized text is compiled, preserving the original document structure and applying spelling or grammar checks for accuracy. Real-world applications. OCR is used to extract data from invoices, receipts, forms, handwritten notes, and more, making information instantly accessible and searchable, saving time and reducing manual effort across countless industries.
Field extraction transforms raw text from optical character recognition, or OCR, into structured, meaningful business data. While OCR identifies what text is present, field extraction determines what that text means and where it belongs. OCR output ingestion. The process begins by ingesting OCR output, which includes not just the extracted text, but also positional metadata, confidence scores, and layout information. This context is crucial for accurate field identification. Field detection and candidate identification. Next, potential data fields are detected. Template-based methods use predefined layouts and keywords, while machine learning models, including transformer-based approaches, learn patterns from example documents. Generative artificial intelligence can also match text to schema fields using prompts and minimal training examples.
Field mapping and association. Once candidates are found, they are mapped to specific fields using techniques like proximity analysis, reading order, and linguistic pattern recognition. For tables, specialized neural networks and graph-based methods help associate rows and columns with the correct fields. Data normalization and standardization. Extracted values are then standardized. Dates, currencies, and units are converted to consistent formats, abbreviations are expanded, and data is validated to ensure accuracy and completeness. Integration with business systems. Finally, the structured data is integrated into business systems, mapped to database schemas or API formats, and quality metrics are reported to ensure reliable downstream use.
Question 1. Which of these statements accurately defines AI information extraction? Using SQL code to query a database. Copying files from cloud storage to local disks. Analyzing unstructured content to identify and extract relevant fields and values.
The correct answer is option C. Question 2. How is OCR used in the information extraction process? Online content retrieval, OCR, is used to copy cloud data to a local device for processing. Optical character recognition, OCR, is used to convert images of text into machine-readable text data. Open conversion routine, OCR, is a method for converting JSON data into images. The correct answer is option B. Question 3. How does generative AI enhance the data extraction process? By using semantic language models to accurately match extracted values to data fields. By manually coding extraction rules for each document type. By generating new documents from scratch. The correct answer is option A. Get started with AI applications and agents on Azure.
Artificial intelligence, or AI, refers to systems designed to perform tasks that usually require human intelligence, like reasoning, problem solving, perception, and understanding language. AI applications use these capabilities to create software that feels more adaptive and responsive than traditional programs. How AI applications work. At the core of every AI application is a machine learning model. These models are trained to recognize patterns in data and make predictions or generate outputs. When you interact with an AI application, the model uses what it has learned to respond intelligently to new inputs. Industry examples. AI applications are transforming industries. In healthcare, AI-powered diagnostic tools analyze medical images to help doctors detect diseases more accurately. In finance, AI systems monitor transactions in real time to spot fraud. Retailers use AI to recommend products based on customer preferences, while manufacturers rely on predictive maintenance to reduce downtime. Education benefits from intelligent tutoring systems that adapt to each student's needs. Building AI applications with Microsoft. Microsoft provides the infrastructure and services needed to build secure, scalable AI applications. With Azure, developers can streamline AI development, integrate with Microsoft Foundry, and innovate rapidly. This foundation supports everything from data storage and security to user interfaces and application logic, enabling enterprise-scale AI solutions.
Get started with AI in Azure.
Artificial intelligence, or AI, refers to systems designed to perform tasks that usually require human intelligence, like reasoning, problem solving, perception, and understanding language. AI applications use these capabilities to create software that feels more adaptive and responsive than traditional programs. How AI applications work. At the core of every AI application is a machine learning model. These models are trained to recognize patterns in data and make predictions or generate outputs. When you interact with an AI application, the model uses what it has learned to respond intelligently to new inputs. Industry examples. AI applications are transforming industries. In healthcare, AI-powered diagnostic tools analyze medical images to help doctors detect diseases more accurately. In finance, AI monitors transactions in real time to spot fraud. Retailers use AI to recommend products based on customer preferences, while manufacturers rely on predictive maintenance to reduce equipment downtime. Education benefits from intelligent tutoring systems that adapt to each student's needs. Building AI applications with Microsoft. Microsoft provides the infrastructure and services needed to build secure, scalable AI applications.
With Azure, developers can streamline AI development, integrate with Microsoft Foundry, and innovate rapidly. This foundation supports everything from data storage and security to user interfaces, enabling enterprise-scale AI solutions.
Microsoft Azure is one of the world's leading cloud platforms. Instead of running everything on your own computer or server, Azure lets you use powerful services over the internet, making modern applications easier to build and scale. Core Azure Services. Azure offers 4 main categories of services. Compute lets you run applications in the cloud, scaling up or down as needed. Storage allows you to securely save and manage data from files to backups. Networking connects your resources and ensures secure, efficient communication. App services provide ready-made platforms for building and hosting applications without managing servers.
Azure's organizational structure. Azure organizes access and management by tenants, subscriptions, resource groups, and resources. A tenant is your organization's secure home base in Microsoft's cloud. Subscriptions are billing containers for your resources. Resource groups help you manage related assets together. Resources are individual services like databases or storage accounts, each with unique settings and permissions. Managing Azure resources. You can manage Azure resources through the Azure portal at portal.azure.com or programmatically using code or scripts. This makes deployments faster, more reliable, and easier to automate, especially for large-scale AI applications. Why Azure matters? Azure empowers organizations to build secure, scalable applications and harness advanced AI, all while simplifying management and cost control.
Security and networking. Building secure AI applications starts with a strong foundation. Azure is secure by design, offering built-in identity, access control, and network isolation. With Azure Entra ID, only the right people and services can access your AI resources. Secrets like API keys are safely stored in Azure Key Vault, never in your code. Hosting and scaling. To run and grow your AI applications, Azure provides flexible hosting options. Use Azure Kubernetes Service for managing containers or Azure App Service to quickly deploy web apps and APIs. Scaling is simple. Add more instances to handle demand or increase resources for existing ones. Azure automates scaling based on real-time needs.
Data storage. AI applications depend on reliable data storage. Azure offers options like Azure SQL Database for critical workloads, Azure Cosmos DB for globally distributed data, and Azure Database for PostgreSQL for intelligent solutions. These services store everything from training data and user input to logs and configuration, ensuring your AI app operates smoothly and securely. AI capabilities and management. To bring your AI solutions to life, Microsoft Foundry provides an enterprise-grade platform for developing and operating AI agents securely on Azure. Administrators can manage resources through the Azure portal or automate deployment with scripts, making it easy to deliver scalable, secure AI applications tailored to your needs. Microsoft Foundry is an enterprise-grade platform as a service for building, deploying, and managing artificial intelligence applications and agents. It brings together models, agent orchestration, monitoring, and governance in one secure platform, making it easier for developers to create production-ready AI solutions. Models and agents. Foundry's unified model catalog offers thousands of options, including Microsoft, OpenAI, Anthropic, Mistral, Cohere, MetaLlama, and more. Developers can browse, evaluate, and deploy models with full lifecycle support. At its core, Foundry uses an agent-first approach, letting teams build intelligent, task-oriented agents that automate workflows and interact with data using built-in orchestration. Tools and knowledge. Foundry provides a suite of Azure services for speech, vision, language, and document intelligence. With Foundry IQ, agents access a permission-aware knowledge layer, drawing from internal and external sources like Azure Blob Storage or SharePoint, ensuring answers are accurate, grounded, and secure. Projects and portal. AI assets are organized into Foundry projects within Azure resources. The Foundry portal offers a modern web interface for developing, testing, and managing models, agents, and tools, with the Ask AI agent helper available for guidance. Workflow example. Sign in, create a project, pick and deploy a model, experiment in the playground, and integrate the model into your application. Microsoft Foundry lets you define models and agents for custom artificial intelligence applications, all accessible through the cloud. These resources are made available via application programming interfaces, or APIs, which allow your applications to interact with Foundry over the internet.
Types of endpoints. Foundry uses API endpoints as service entry points. Each endpoint has a unique HTTP address, similar to a website, but designed for client application code. There are two main types: project-level endpoints, which manage your overall Foundry project and resources, and model endpoints, which let you send prompts to deployed models. How endpoints work. Applications communicate with endpoints using representational state transfer, or REST, interfaces. REST requests include headers for authentication in data format and a body in JSON format. For example, you might send a prompt like, "What is an AI application?" and receive a detailed response in JSON.
Security and access. To keep your Foundry resources secure, endpoints require authentication. Applications must provide a valid API key or a token from Microsoft Entra ID credentials, ensuring only authorized access to your models and data. Using REST and SDKs. While you can't interact directly with REST interfaces, most developers use software development kits, or SDKs, in languages like Python or JavaScript. SDKs simplify building secure, scalable solutions on the Azure Cloud Platform.
Question 1. Which statement best explains the relationship between AI and ML? AI and ML are interchangeable terms, both refer to systems that mimic human intelligence without distinction. ML focuses exclusively on generative tasks like creating text and images, whereas AI is limited to decision-making and planning. AI is the overarching goal of creating systems that exhibit human-like intelligence, while ML is a data-driven method used to achieve AI by learning patterns from data. The correct answer is option C. Question 2. How does Microsoft Foundry relate to Azure? AI and ML are interchangeable terms. Both refer to systems that mimic human intelligence without distinction. ML focuses exclusively on generative tasks like creating text and images, whereas AI is limited to decision-making and planning. AI is the overarching goal of creating systems that exhibit human-like intelligence, while ML is a data-driven method used to achieve AI by learning patterns from data. The correct answer is option A. Question 3. Which statement best describes how keys, secrets, and endpoints work together in an Azure-based AI application? The key is the location where model responses are stored in Azure Key Vault, and the endpoint retrieves those responses from Azure. The endpoint stores sensitive values for an AI application, and the key determines how much data the endpoint can return. The endpoint is a URL for calling a deployed model, and the key, stored as a secret in Azure Key Vault, authenticates the request made to that endpoint. The correct answer is option C.
Question 4. Which statement best describes a client application in the context of an AI solution built with Foundry? A client application is the environment that hosts the model, runs inference, and returns results. A client application is a program the user interacts with, such as a web app or mobile app, that sends requests to a model endpoint and displays the response. A client application is a standalone Azure service that automatically generates API keys for model deployments.
The correct answer is option B.
Get started with generative AI and agents in Azure.
Generative artificial intelligence, or generative AI, is a branch of artificial intelligence focused on creating new content. In just a few years, it has transformed how we work and expanded what technology can achieve, even outpacing the expectations of experienced developers. Real-world use cases. Today, generative AI powers a range of innovative applications. In marketing, Microsoft Copilot helps companies automatically write product descriptions, blog posts, and social media content, saving time and ensuring brand consistency. For customer support, AI-powered virtual agents respond to inquiries in natural language, providing round-the-clock assistance and reducing the workload for human agents. Developers use GitHub Copilot to generate code snippets and entire modules from natural language prompts, accelerating software development. Designers and content creators leverage Microsoft Foundry's model catalog to generate images and videos for campaigns or storyboards, often starting from just a text description. In education, generative AI creates personalized quizzes and study guides tailored to each student's learning style. Microsoft Foundry and its tools. Microsoft Foundry offers a comprehensive ecosystem for AI development. Users can explore the model catalog, test and configure models in the Foundry playground, and integrate solutions using the OpenAI-compatible Responses API and Project API for consistent deployment. Bringing it all together. Generative AI, supported by Microsoft Foundry, is reshaping industries by making content creation, support, and learning more efficient, creative, and accessible than ever before. Generative AI and agentic solutions are powered by large language models, or LLMs, which generate a wide variety of responses for different needs. From lightweight phone apps to specialized government tools, the right model makes all the difference. Microsoft Foundry Overview. Microsoft Foundry is an integrated environment for discovering, evaluating, deploying, and operating generative AI models. It brings together a rich model catalog, flexible deployment options, and built-in governance, empowering teams to build copilots, agents, and AI-powered applications with enterprise confidence. Exploring the model catalog. Foundry's model catalog is a central hub for discovering generative AI models from Azure, partners, and open-source communities. You can filter by source, capabilities, or task, and compare models like GPT 5.x, Claude Opus 4.5, and Mistral Large 3 for your specific needs. Evaluating and comparing models. Foundry simplifies model selection with benchmarking results, leaderboards, and side-by-side comparisons. Evaluators measure quality, safety, and effectiveness using both classic metrics like accuracy and AI-assisted metrics such as groundedness and coherence, ensuring responsible and high-performing AI solutions. Deploying models with flexibility. Once you select a model, Foundry offers flexible deployment options, customizable performance, and secure endpoints. You can adjust tokens per minute, monitor usage, and ensure compliance, making it easy to scale and manage AI-powered applications reliably. Explore Microsoft Foundry to unlock the full potential of generative AI. The Foundry Playground is the simplest way to interact with your deployed AI models. Inside the Foundry portal, you can experiment with prompts, compare different models, and fine-tune settings before writing any code. It is designed for quick testing and iteration. Key configuration parameters. In the Playground, you can adjust several important parameters that shape how your model responds. Temperature controls creativity versus determinism, letting you choose between more imaginative or predictable outputs. Max output tokens set the maximum length of the model's response, which also impacts cost and performance. You can also set system instructions to guide the model's behavior. System instructions versus user prompts. System instructions define the model's role and guardrails, such as you are a helpful step-by-step tutor, cite sources, decline medical advice. User prompts, on the other hand, are the actual questions or requests you want answered. From Playground to code. Once you have settings that work, the Playground provides code snippets to call your model using the OpenAI-compatible Responses API. This code can be the foundation for building your own lightweight chat client with the Foundry SDK. Models versus agents in Foundry. In Foundry, models provide raw intelligence, while agents are task-oriented workers built on top of those models. Agents in Microsoft Foundry are reusable AI components powered by generative AI models like GPT 4.1. Unlike single-use prompts, agentic AI defines consistent, workflow-like behaviors that can be integrated across apps, services, and experiences for more dynamic automation. Building an agent in Foundry. To create an agent in the Foundry portal, start by selecting a generative AI model. Next, write system instructions that define the agent's role, behavior, and output style.
For example, you might specify, "You're a helpful scheduling assistant who returns answers in concise bullet points." What sets agents apart is their ability to use tools and knowledge sources, making them more capable than standalone models. Tools and knowledge. Tools in Foundry are actions the agent can take, such as searching the web, querying databases, or running custom functions. Knowledge refers to external documents or datasets the agent can access, enabling accurate, context-rich responses. When knowledge is used, the agent's answers include citations for traceability. Using and publishing agents. Agents can be integrated into client applications using the Foundry Project Software Development Kit, or SDK, and Project Application Programming Interface, or API. Publishing an agent gives it a dedicated, stable endpoint, making it easy to share and integrate securely into enterprise systems.
Question 1. What best describes Foundry's model catalog? A catalog consisting of only Microsoft-exclusive foundation models, a central hub to discover, filter, compare, and test many generative AI models from multiple providers, a tool that replaces the need for an Azure subscription.
The correct answer is option B.
Question 2. Which statement best describes a foundation model in Microsoft Foundry? A small, task-specific model that must be fine-tuned before it can perform any useful function. A benchmarking tool used to compare different model families. A large, pre-trained model that provides general capabilities and can be used immediately or customized.
The correct answer is option C. Question 3. In the Foundry portal, what is the primary benefit of using the model playground before writing code? It lets you test prompts, compare models, and capture working settings that you can reuse in code. It deploys the model for you and removes the need to use an API. It replaces system instructions by automatically generating the best system prompt for every scenario. The correct answer is option A. Question 4. What is the primary outcome of publishing an agent in Microsoft Foundry? It converts the agent into a managed Azure resource with a stable endpoint that you can share and integrate without exposing your Foundry project or source code. It automatically reduces costs by making the agent free to run, regardless of model tokens, tools, or connected data services. It replaces the need for the project API by allowing the agent to be called only through the Foundry portal UI. The correct answer is option A. Question 5. In the Python example, which line is responsible for calling the published agent rather than calling a model deployment directly when generating a response? The correct answer is option C. Get started with text analysis in Azure. Artificial intelligence is transforming the way we understand written information. At the heart of this transformation is natural language processing, or NLP.
NLP allows machines to interpret, analyze, and respond to human language, making it possible to extract meaning and structure from text that was once unstructured and difficult to process. Key applications of text analysis. Text analysis, powered by NLP, automatically examines written content to uncover valuable insights. For example, businesses can analyze customer reviews, support tickets, and survey responses to spot trends and address dissatisfaction early, ultimately improving customer experiences. In healthcare, text analysis helps extract clinical details from medical documents, identifying symptoms, medications, and diagnoses to support faster and more accurate decisions. Financial institutions use text analysis to process contracts and loan applications, extracting key details like interest rates and compliance risks, which reduces manual review time and increases accuracy. In the legal field, text analysis summarizes lengthy case files and agreements, highlights important clauses, and classifies documents by topic, enabling attorneys to work more efficiently and make informed decisions.
Introduction to Microsoft Foundry. Microsoft Foundry is the platform for building artificial intelligence applications and agents on Azure. The new Foundry portal lets you build, test, and deploy AI solutions using a web-based interface, offering both a classic and a new user experience. General-purpose AI models. In the Foundry portal, you can deploy general-purpose artificial intelligence models for text analysis. These models are trained on vast amounts of data, allowing them to handle tasks like sentiment analysis, entity extraction, summarization, translation, and more, all through natural language prompts. No extra configuration or training is needed. Key phrase extraction and entity recognition. With general-purpose models, you can extract key phrases and identify entities from unstructured text. For example, analyzing a restaurant review might highlight phrases like fantastic meal or strawberry cheesecake and recognize entities such as people, locations, and dates.
Sentiment analysis and summarization. Sentiment analysis classifies text as positive, negative, or neutral. You can even get sentence-by-sentence breakdowns. Summarization condenses long documents into concise paragraphs, making information easier to digest. Azure Language Tools. For more predictable results, Azure Language in Foundry offers purpose-built analyzers. These tools provide structured, deterministic output, ideal for automated workflows. Language and PII detection. Azure Language detects languages and identifies personally identifiable information, helping organizations comply with privacy regulations and manage multilingual content efficiently.
A client application is a program you write that connects to a service or model, sending requests and receiving results automatically. This allows you to process large volumes of text or integrate AI analysis into your workflow. Connecting to AI services. To connect your application to an AI service, you use an Application Programming Interface, or API. APIs define how software communicates. Client libraries, like those from Microsoft Azure, provide ready-made code to simplify these connections, making it easier for developers to interact with AI models. Using the OpenAI Python library. With Microsoft Foundry and Azure OpenAI, you can deploy general-purpose models and interact with them using the OpenAI option. The official OpenAI Python library lets you build Python applications that send prompts to deployed models. By configuring environment variables and creating a client object, your code can securely send requests and receive AI-generated responses for tasks like sentiment analysis.
Using the Azure Language SDK. The Azure Language Software Development Kit, or SDK, is a client library for Azure Language in Foundry tools. It enables developers to add natural language processing features such as language detection and redacting personally identifiable information to their applications. Methods like detect language and recognize PII entities return structured results, including language codes, confidence scores, and redacted text.
AI agents are powerful tools that can reason, plan, and interact with external services. But when it comes to structured text analysis, generative AI models alone are not enough. That is where Azure Language in Foundry tools comes in. What is MCP? The Model Context Protocol, or MCP, is an open standard that connects AI agents to external tools and data sources. Think of MCP as a universal adapter. Instead of building custom integrations for every service, agents connect to an MCP server that exposes capabilities in a standard way. How MCP works? MCP uses a client-server architecture. The AI agent acts as the client, sending requests and receiving responses. The MCP server listens for those requests, executes the right capability, and returns structured results, like sentiment scores or key phrases. Azure Language MCP Server. The Azure Language MCP Server is a managed service that brings Azure Language features such as named entity recognition and sentiment analysis directly to your agent. Since it follows the MCP standard, you do not need to manage authentication or call APIs directly. Using Azure Language in Foundry.
In the Foundry portal, simply deploy your model as an agent and add the Azure Language MCP server as a tool. Now, your agent can combine reasoning with precise text analysis for tasks like language detection or redacting personal information.
Question 1. You need to analyze text where the same input must return structured results based on statistical techniques. Which approach is most appropriate? The OpenAI Responses API because it can follow natural language instructions. The Azure Language SDK because it returns deterministic structured output. The Chat Playground in Foundry because it supports follow-up questions.
The correct answer is option B.
Question 2. What is the purpose of the client object in the Azure Language SDK? It stores the application's user interface settings. It helps application code communicate with the Azure Language Service. The client object stores the text that needs to be analyzed.
The correct answer is option B.
Question 3. What is the main purpose of the Azure Language MCP server? To automatically generate website layouts for an agent. To expose Azure Language capabilities to agents through the Model Context Protocol.
The correct answer is option C.
Get started with speech in Azure. AI speech capabilities are transforming the way we interact with technology by allowing us to manage systems with voice commands, ask questions out loud, and receive spoken answers. These tools make digital experiences more natural and accessible for everyone. Core capabilities. To enable these interactions, an AI system needs two essential features: speech recognition, which detects and interprets spoken input, and speech synthesis, which generates spoken output. Together, these capabilities allow for seamless communication between humans and machines using natural language. Real-world applications. AI speech technology is already making a difference across industries. In healthcare, doctors can dictate patient notes, saving time and reducing manual typing. Customer support centers transcribe calls in real time for easier review and sentiment analysis. Media platforms generate live captions, improving accessibility for diverse audiences. In education, language learning apps provide pronunciation feedback, helping students practice speaking. Retailers use voice-enabled assistants to answer customer questions and provide product information. Azure Speech example. Microsoft's Azure Speech in Foundry tools offer speech-to-text, text-to-speech, and speech translation. With both pre-built and custom models, users can transcribe audio, identify speakers, and even create custom voices, making AI speech integration flexible and powerful. Speech recognition, also known as speech-to-text, is an artificial intelligence capability that converts spoken words into written text. This technology powers apps and agents to respond to voice input, making interactions more natural and accessible. How Azure Speech works. Azure Speech uses advanced models to transcribe audio. An acoustic model transforms audio into phonemes, which are sound representations, while a language model maps those phonemes to actual words. The result is accurate text that can be used for captions, transcripts, or automated notes. Exploring Azure Speech in Microsoft Foundry. In the Microsoft Foundry portal, you can experiment with Azure Speech's speech-to-text feature. Simply upload an audio file or record your voice in the Foundry playground and watch as your speech is transcribed instantly for testing and exploration. Using the Azure Speech SDK. To add speech-to-text to your own application, use the Azure Speech Software Development Kit, or SDK. The SDK handles audio capture, secure transmission, and returns transcribed text, letting developers focus on building great user experiences.
Real-time and batch transcription. Azure Speech supports both real-time and batch transcription. Real-time transcription is perfect for live presentations, while batch processing lets you transcribe stored audio files asynchronously, making it flexible for many scenarios. Introduction to text-to-speech. Speech synthesis, also known as text-to-speech or TTS, transforms written text into spoken audio. This technology is used for reading messages aloud, generating spoken responses, and broadcasting announcements, making digital content more accessible and engaging for everyone. How Azure Speech works. Azure Speech offers a powerful text-to-speech API that converts text input into natural-sounding speech. The system tokenizes the text, assigns phonetic sounds, and organizes them into prosodic units like phrases or sentences. Using neural networks, Azure's neural voices overcome common limitations in speech synthesis, such as unnatural intonation, resulting in more lifelike audio. You can select from multiple voices, languages, and regional pronunciations, or even create custom voices. Exploring the Foundry Playground, the Azure Speech Text-to-Speech Foundry Playground lets you experiment with different synthetic voices. You can adjust parameters like speed and pitch and instantly generate audio from your chosen text, tailoring the output to your needs. Using the Azure Text-to-Speech SDK. The Azure Text-to-Speech Software Development Kit, or SDK, enables developers to integrate voice synthesis into applications. The SDK handles authentication, network communication, and audio formatting, allowing you to focus on your app's experience. You can play or save the generated audio easily.
Introduction to AI agents and speech-to-speech. AI agents are software programs designed to understand, decide, and act independently to help users reach their goals. One exciting goal is enabling real-time spoken conversations, making interactions with technology feel as natural as talking to another person. How speech-to-speech works. Speech-to-speech technology lets applications take spoken audio as input and respond with spoken audio as output. This combines speech-to-text, language processing, and text-to-speech into a seamless pipeline. The system listens, understands, or transforms what was said and replies with synthetic speech, creating a smooth conversational experience. Real-world uses and Azure Voice Live. Speech-to-speech powers voice assistants, speech translation, hands-free navigation, accessibility tools, and customer support bots. Azure Speech includes Voice Live, a service that brings all these capabilities together. The Voice Live API allows developers to build real-time voice conversations, handling everything from speech recognition to generating spoken responses. Building with Azure Voice Live. Developers can use the azure.ai.voicelive package in Python to create custom applications. Sample code is available in the Foundry portal, making it easy to get started. With Azure managing the backend, you can focus on building engaging, speech-capable conversational agents. Question 1. Why would a developer use the Azure Speech-to-Text SDK instead of only using the Foundry Playground? The SDK replaces the need for Azure speech models. The SDK is required to upload audio files to the Foundry portal. The SDK allows speech recognition to be added directly into application code.
The correct answer is option C.
Question 2. What does the Azure Text-to-Speech SDK handle for developers? Only selecting the voice and writing audio files manually? Authentication, network communication, and audio generation? Storing synthesized audio permanently in Azure Storage?
The correct answer is option B.
Question 3. What role does the Voice Live Python SDK, Azure AI Voice Live, play in a voice-enabled agent? It stores audio recordings permanently in Azure Storage. It replaces the need for microphones and speakers on the user's device. It opens a real-time connection, streams audio, and handles spoken responses, interruptions.
The correct answer is option C.
Get started with computer vision in Azure.
Computer vision is a branch of artificial intelligence that empowers machines to interpret and understand visual information from the world. By analyzing images, videos, and live camera feeds, computer vision automates tasks that once required human eyes and judgment. Core capabilities of computer vision. AI models in computer vision can identify and analyze objects, recognize patterns, read text within images, and interpret entire scenes. Some advanced models even generate new visual content, allowing systems to not only see, but also create images and videos, much like a human artist or designer. Real-world applications. Computer vision is transforming industries. In manufacturing, AI vision systems inspect products on assembly lines, detecting defects and improving quality control. In healthcare, computer vision helps radiologists analyze X-rays and MRIs, highlighting anomalies and supporting early diagnosis. Retailers use AI vision to monitor shelves, ensuring products are stocked and correctly placed. Autonomous vehicles rely on computer vision to recognize road signs, lane markings, and pedestrians, enabling safe navigation in complex environments. Looking ahead. As computer vision continues to evolve, its applications will expand even further. Platforms like Microsoft Foundry on Azure are making it easier for enterprises to develop and deploy advanced visual AI solutions, unlocking new possibilities for innovation and efficiency.
What are multimodal AI models? Multimodal AI models are artificial intelligence systems that can understand and process more than one type of data at the same time, such as text, images, audio, or video. This means they can analyze both written and visual information together. How multimodal models work. These models accept multiple inputs in a single request. For example, you can provide a text instruction and attach an image. The model then processes both inputs simultaneously, generating a response that combines its understanding of the text and the image. Real-world applications. Multimodal models are used in many AI applications. They can describe images in natural language, answer questions about photos, analyze screenshots, or explain diagrams. For instance, a support app might analyze customer-submitted photos, or a learning tool could explain a chart in plain language.
Vision-enabled GPT models in Microsoft Foundry. Microsoft Foundry offers vision-enabled GPT models like GPT 4.1 and GPT 5.1, which can process both text and images. These models are designed for flexible visual reasoning, making it easier to build intelligent, vision-based solutions without deep computer vision expertise. Building with multimodal models. Developers can use the OpenAI Python SDK and the Foundry platform to build applications that analyze images and respond in natural language. By combining text and image inputs, these models enable smarter, more interactive AI experiences for users.
Microsoft Foundry offers powerful image generation models that turn text descriptions into stunning visuals. These models are designed for a range of creative and enterprise needs, making it easy to generate original images for branding, marketing, or content creation. Model options. For most projects, Microsoft recommends starting with the GPT Image 1 family, especially GPT Image 1.5. This model delivers high-fidelity, enterprise-grade image creation and editing with strong prompt alignment and consistency. GPT Image 1 is a versatile, general-purpose model, while GPT Image 1 Mini is optimized for lower cost and faster results. Foundry also supports third-party models like Flux from Black Forest Labs, which are open source and known for photorealistic, stylistically flexible images. How to use. You can deploy these models in a Foundry resource, test them in the Foundry Playground, or access them programmatically using the OpenAI Responses API or image generation APIs. Simply describe the image you want, and Foundry generates it in minutes. Coding example. With the OpenAI Python SDK, you can generate images by providing a prompt and calling the API. The SDK supports both new image creation and editing, making it ideal for media, publishing, and creative applications.
Microsoft Foundry is transforming how we create visual content, moving beyond static images to dynamic video. With Foundry's video generation models, you can easily produce original video clips from simple text prompts or images. Sora 1 and Sora 2 Overview. The first model, Sora 1, lets you generate short videos from text or images, supporting various resolutions and durations. It is available through the Azure OpenAI service and the Foundry Video Playground. Sora 2, now in public preview, is a major upgrade. It supports text, image, and video-to-video remixing, introduces audio generation, and offers more realistic results. Sora 2 is accessible via the Azure OpenAI V1 API and the Foundry Video Playground, using the Foundry Playground and REST API. To experiment, use the Foundry Portal Playground to set video dimensions and duration, then submit your prompt. For automation, the Foundry REST interface lets you create, monitor, and download video jobs programmatically. Video generation typically takes 1 to 5 minutes and runs asynchronously, so you can pull for job status and retrieve the finished MP4 file. Responsible AI and final thoughts. Both Sora models include responsible AI safeguards, restricting certain content types. Microsoft Foundry's video generation tools are continually improving, making it easier than ever to bring creative ideas to life.
Question 1. What is a multimodal model? A model that can only process images but not text? A model that can understand and work with more than one type of data, such as text and images? A model that generates video content only?
The correct answer is option B.
Question 2. How can developers programmatically generate images using Foundry image generation models? By sending text prompts through the OpenAI Responses API using a deployed image model, by uploading images through the Foundry Playground UI, by calling the GPT 4.1 model endpoint.
The correct answer is option A.
Question 3. When you generate images programmatically using the OpenAI Python SDK with Microsoft Foundry, which value should you pass as the model parameter in the request? The original base model name, for example, GPT Image 1.5? The deployment name you gave the image generation model in your Foundry resource? The name you gave your Foundry resource?
The correct answer is option B.
Question 4. Why is video generation with Sora models in Microsoft Foundry handled as an asynchronous job? Because video generation requires user interaction during rendering. Because the REST API doesn't support synchronous requests. Because video generation is resource-intensive and takes time to complete.
The correct answer is option C.
Get started with AI-powered information extraction in Azure.
Anyone who has ever processed invoices or forms by hand knows how time-consuming and challenging it can be. Fortunately, artificial intelligence is transforming this process. AI-powered information extraction allows organizations to unlock valuable insights from data that would otherwise remain hidden in documents, images, audio, or video files. Real-world scenarios. Consider a few practical examples. For expense claim processing, companies can now extract descriptions and amounts directly from scanned receipts. In customer support, agencies analyze recorded calls to identify common issues and resolutions. Even in tourism, organizations estimate visitor numbers by analyzing video footage and images. These scenarios show how AI can automate and enhance information extraction across industries.
How Azure Content Understanding works. Microsoft Azure Content Understanding, available in Foundry tools, uses artificial intelligence to extract structured information from unstructured content. It identifies entities, fields, relationships, and meaning within documents, images, audio recordings, and video files. This technology turns content like PDFs, forms, contracts, and meeting recordings into searchable, machine-readable data. Benefits and next steps. By automating information extraction, Azure Content Understanding saves time and reduces manual effort. Organizations can quickly analyze and search their data, gaining actionable insights. Next, discover how to extract structured data from unstructured documents and forms using these advanced AI tools.
Businesses rely on documents like invoices and receipts, but manual data entry can be slow and error-prone. Azure Content Understanding automates this process, turning unstructured content into structured, usable data with the help of artificial intelligence. How Azure Content Understanding extracts data. First, you submit your documents to Azure Content Understanding. The service uses advanced artificial intelligence, including optical character recognition, or OCR, speech recognition, and natural language understanding to analyze your content. It then returns structured results, often in JSON or JavaScript object notation, a format that is easy for both humans and machines to read and process. Schemas and analyzers. What sets Azure Content Understanding apart is its schema-driven approach. A schema defines exactly what information you want to extract, such as vendor name, invoice number, or item details. Analyzers apply these schemas, ensuring consistent extraction even if labels differ or are missing. This means you get reliable, structured data every time. Using the service. You can use Azure Content Understanding through the Foundry portal's visual interface or programmatically with the Content Understanding API. Pre-built and custom analyzers are available, making it easy to automate data extraction and streamline your business processes. Business data is no longer just text. Today, valuable information is hidden in audio and video files, like recorded calls or video conferences. Azure Content Understanding helps businesses unlock this data, making it easy to extract and analyze key insights. Extracting structured data from audio. With Azure Content Understanding, you can turn audio files into structured data. For example, after analyzing a voicemail, you might extract the caller's name, a summary of the message, requested actions, callback number, and alternative contact details. Extracting structured data from video. Azure Content Understanding also works with video. Imagine analyzing a conference room image to identify the location, count in-person and remote attendees, and get a total head count. You can even expand your schema to capture who spoke, what was discussed, and assigned actions. Using the Foundry portal. The classic Foundry portal lets you quickly test audio or video analyzers, upload your media, review transcripts, and see extracted insights in structured JSON format, ready for further processing. Building client applications. Developers can use the Content Understanding API to automate analysis, integrating these insights directly into business workflows and applications. Question 1. What is the key advantage of using Azure Content Understanding over basic optical character recognition? Azure Content Understanding extracts text faster by skipping image preprocessing. Azure Content Understanding understands document structure and maps extracted data to a defined schema. Azure Content Understanding extracts structured data, while OCR extracts the relationship between words in text.
The correct answer is option B.
Question 2. What is the primary role of an analyzer in Azure Content Understanding? It defines how content is processed and what structured data is returned. It stores extracted data in a database. It converts JSON output into human-readable text.
The correct answer is option A.
Question 3. When you use the Azure Content Understanding Python SDK, what happens after you submit content for analysis? The results are returned immediately in the same request. The analyzer retrains itself on the submitted content. You must poll a URL until the analysis job completes.
The correct answer is option C.
Welcome to Tech with Shaping Pixel. In this video, we're diving into the latest real exam questions and answers for the Microsoft Azure AI Fundamentals A901 certification. If you haven't subscribed to our YouTube channel yet, we'd love for you to join our growing community. Just hit that subscribe button. Downloadable PDF of these questions and answers, you can grab it from our website, www.shapingpixel.com. Full link is in the description below. Let's get started.